All right, let's go ahead and start going over this. We are identifying the transformation rule, meaning, okay, it's a translation and it's moved this much, up and down or left and right. It's a reflection across a specific axis, or it's a rotation by a specific degree in a certain direction. And I stated that you can only use translation one time only, because otherwise everybody could be like, oh, it's a translation for every single one of them. Okay, every single figure can be technically translated to meet where it needs to go. However, only one time can you use the translation for this. So, an easy rule to know, if the numbers are very different, like they're not like the same, like here, the numbers are somewhat similar, aren't they? Right? You've just got positives and negatives of the same type of number. So those typically indicate that it's either going to be a reflection or a rotation. It's when the numbers are very different looking that they're either going to be a translation or they're going to be what we learned today, which is called a dilation. So the only one that has it where the original point looks very different than the prime point is what number? What problem? Number 3. Number 3 is the only one that we're starting off with -4, 11, and then we're translating it to very different values. So that would be the only one that we can consider to be a translation purely. The rest of these are going to be some form of reflections or rotations. So let's go ahead and start with problem number 1. We started at 7, 15, and then we went to -7, -15. What transformation changes the values to their opposites for both the x and the y? Zheng? A rotation of 180 degrees. So when we started here, we started at x and y, and then it happened to go to an opposite of an x and an opposite of a y. The rule that goes opposite of x and opposite of y is going to be that rotation by 180 degrees. You don't have to state clockwise or counterclockwise because of the fact that it's the same exact thing. Okay? For problem 2, -2, 5 becomes +2, 5. So what rule has us starting at x and y and then changing it to the opposite of x and y? What rule is going to have us going from xy to opposite of xy? Yuchan? The reflection across the y-axis. Very good. When we reflect across the y, it changes the x to the opposite. When we reflect across the y, it changes your x to the opposite value. So it's a reflection across the y-axis. And then problem number 3, yeah, we identified that it would be a translation. But what are we translating by? That's the important thing. So we know we're going to translate. So we're going from -4 to a -3, and then we're going from 11 to an 8. So -4 to a -3, is that value increasing or decreasing? Increasing. And what is it increasing by? 1. So we know that the rule is going to be 1 unit to the right, or you could put x plus 1. And then when we're starting at our y, starting at an 11, and then we're going to an 8, are we increasing or decreasing? Decreasing. And what are we decreasing by? 3. We decreased by 3, so y minus 3, which means that we are going 3 units down, or y minus 3. Either one of those would have been perfectly acceptable for your answer. Okay? Let's take a look now at number 4. 6, -3 goes to -3, -6. So we're starting at this x value, this y value. Now it seems to be that our y value came to the front and stayed exactly as it was. Our x value went to the back and it became an opposite value. So what transformation has us going to y opposite of x? Y opposite of x. Which one's that going to be, Alex? Okay, rotation clockwise 90 degrees or counterclockwise 270. Good. So we rotate clockwise 90 degrees or counterclockwise 270 degrees. Okay. These are when you need to have those rules memorized. You need those rules to be memorized. Okay, problem 5. We are starting at 5, -1, and then we went to 5 and +1. Started at 5, -1, so there's our xy. Then we went to x and opposite of y. X and opposite of y. Which one has us doing x opposite of y? Armando? Good. So we reflected across the x-axis. Okay, if the y changes to the opposite, it's a reflection across the x-axis. All right, and then our last one, we have -4, -9 becomes -9, 4. Okay, so here's our x and here's our y. Our y came to the front. Our y came to the front, and our x, again, went to the back and was an opposite. We should have already known this because it's the same thing, right? It's another rotation, again, a rotation clockwise 90 degrees, counterclockwise 270. Okay. Any questions? All right. So let's talk about our last transformation. And this transformation, see, all of these transformations that we talked about, they still kept the figures congruent. Congruent meaning that they are still the exact same measurement, right? They didn't change anything to do with size. This transformation allows them to be similar. So meaning that they're still going to be the same type of shape, but they're proportional in their size, so they're not exactly the same size. And it's called a dilation. So how many of you have ever been to the eye doctor and they put those drops in your eyes? Right? They say that they're dilating your eyes and your pupils get really big, don't they? It opens them up so that way they can see inside and see if there's anything wrong with your eye. So dilation, you guys might only know it as your pupils getting larger, but it's actually a geometric transformation too, where there is an enlargement, meaning it gets bigger, or a reduction, which means it's shrinking, it's getting smaller. Okay? And dilations, again, they are the only transformation that takes your original figure and changes the size. All the other transformations maintain the size. Okay, all other transformations maintain size. Dilations do not. They are the only ones that have an effect on the size. So maybe you want to highlight that. It's a very important piece of information to know. Dilations are the only transformation that makes the original figure change the size. Now, the scale factor. The scale factor is also known as the K value. Your scale factor is known as your K value, and it's a value that you're multiplying your pre-imaged value by in order to get that dilated image. So we're going to highlight that in blue. Your scale factor is a value, a K value, that you're multiplying your original values by in order to get a dilated image, whether it's an enlargement or a reduction. Now, an enlargement means that your scale factor is going to be greater than 1. Because obviously if we multiply by 1, is it going to change anything? No. If we multiply by 1, it keeps everything the same. But if we multiply by a value greater than 1, it increases the size. Even if it's like 1.000000001, that is going to have an effect on your original value. Very, very minuscule, but still an effect. Okay? A reduction has to shrink it. So it has to be a value that's smaller than 1, but it can't be smaller than 0. Okay? It has to be greater than 0 because you still need to have the shape. You can't have a negative measurement for a shape. Can't have a negative measurement for a shape. Everybody understand that, right? Logically speaking, if you're measuring something, can you have a negative value? No. Okay, so it has to be greater than 0 but less than 1 in order for you to create a reduction, a shrinking of your measurement. Okay, so these are the kind of scale factors that we're talking about. An enlargement and a reduction. Any questions so far? All right, go ahead and turn it over to the back then. On the back, this is your rule that you're going to follow. You start with your original value, x, y, and your rule for dilation is that it's k times x and k times y, where k represents a number greater than 0, represents some number greater than 0. Okay? So this is a rule. So you guys are going to want to get a new index card to create your dilation. Don't do it right now, but you eventually are going to want to create a dilation index flashcard. Okay? Where this is your rule. K times x and k times y. All right, so let's take a look. For problem number 1, the following points are going to be dilated by a scale factor of 1/2. So are we enlarging or reducing? Reducing. This is going to be a reduction because of the fact that the scale factor is 1/2. That's smaller than 1 but greater than 0. So all you're going to be doing is taking each of these points and you're going to multiply them by 1/2. You're going to multiply each of those values by 1/2. So that a prime, if I do 4 times 1/2, that's going to give me a 2. If I do 6 times 1/2, that's going to give me 3. So my point got smaller in value. Essentially, the shape itself is going to shrink. So if we were to plot this shape, this triangle, and then plot the primed triangle, we would see the shrinking. So I want you guys to do B and C on your own, and I'm going to get a piece of graph paper just to show you. But go ahead and do B and C on your own. All right, so let's go ahead and do this one. So for prime B prime, if we multiply 10/8 by 1/2, what will our new B prime value become? Kavya? 5/4. Okay, and then for C prime, we're multiplying 5/14 by 1/2, and what will C prime become? Saranj? Good, 2.5 and 7. It's perfectly fine to be able to have decimal values. And this is what it's going to look like if you were to graph them. So in black, that is my original points. Those are my original triangle points. And then in red, that is the reduction where it's reduced in size by 1/2. Okay, so that's what a reduction would look like. An enlargement would just make it bigger, obviously. Okay. Let's go ahead and take a look at problem number 2. Problem number 2, the scale factor is 9. Is that a reduction or an enlargement? Enlargement. That 9 means that we're going to go ahead and enlarge the shape. So it's an enlargement. So we're just going to be multiplying each of these values by 9. Dilations are very, very simple. Okay, so what will A prime become then? If it goes from -4, 3, it now becomes what? Valentina, what will it become? Good, -36 and 27. Okay, then we've got 1.6 and -5. We've got 1.6 and -5. When we do a scale factor of 9, what is that going to become? Alex? Good. 14.4 and then -45. Okay, any questions? All right, so what you're going to be doing today, we're going to go ahead and have a quizzes on all transformations. That before we begin that, I need to talk to you guys about some of your all's IXLs.